Hi guys, how we doing?
Good, thanks.
How are you?
Surviving? I'm alright. I'm alive still, as you may be able to verify. So we're going to start talking about whatever we're supposed to talk about today. First, I don't know, 1.1 I guess, 1.2. But before that, we haven't had a chance to go over any of the review stuff. So I pulled it up here, which, maybe I'll take half an hour, 40 minutes, and just go over a few questions from this that were giving you trouble. So now is your time to ask me questions. You try any of this?
Can you do number 14?
Can I? I don't know.
Well, if you did mark one as hard.
What's that now?
You did mark one as difficult.
Oh, I didn't mark any of them as difficult. That's not mine. That's the books. That's the author's. That's the author decided number one is not difficult. 14? Oh, okay. That's a tricky one.
Yeah.
All right, so number 14 from the review sheet here says, a moving conveyor is built to rise 1 meter for every 5 meters of horizontal change. Suppose the conveyor runs between 2 floors in a factory. Find the length of the conveyor if the vertical distance between floors is 10 meters. What is number 14? So me, if I were doing this problem, I'd have to draw a picture, because you'll learn very quickly that I draw pictures whenever I can. So I have this conveyor, so this machine that's supposed to be lifting things from one floor to another floor. So this is going to be my first floor. This will be my second. But it tells me that this conveyor rises 1 meter for every 5 meters of horizontal change. So I have, let me draw in a different color actually. I have this conveyor going from the bottom floor to the second floor, say. But I know that for every 1 meter, it rises 1 meter for every 5 meters of horizontal change. So what does that mean at all? What does that mean about anything?
So the slope is 5.
Yeah, so the slope, if it rises 1 for every 5 meters of horizontal change, this problem is trying to tell you that the slope of this conveyor is 1 rise, 5 run. So for every 1 you go up, you go over 5. So what if then, and then what are we asking for? It wants to know at the end of the day, find the length of the conveyor, right? So it's telling me to find the length of the conveyor, this distance, and it's giving me the piece of information that the floors are 10 meters apart. So this distance from here to here is 10 meters, right? It says the vertical distance is 10 meters. So in my mind, what's going on is I see a right triangle, and if I could figure out what this distance was, then I could use my Pythagorean theorem to get d. So what's this distance here?
5.
5, not quite. It would be 5 if I went 1 meter up, right? If I just go 1 meter up, then it would be 5 meters this way.
It's going to be 50.
So it's going to be 50, right? Because you go 10 meters up. So if you go 10 meters up, then that means you have to go 5 10 times. Right? So this entire distance here will be 50 meters. So that still doesn't actually solve the problem, right? We still need to solve for d. So to get to d, I would write the equation d squared equals, actually let me write it this way, 50 squared plus 10 squared equals d squared. Right, Pythagorean theorem, a squared plus b squared equals c squared. And then you could get d by actually squaring this out in square root. At the end of the day, you should get 51. What's that? 10 to 26. Sure. Then get your approximation so you can pick the right one. Normally, I absolutely love exact answers, but since it's multiple choice, you're going to have to get an approximation. about that one? Other questions? What else gave you trouble? 29? Oh, okay, 29's a bear. All right, let's start with 28. So I'll do both of them. Okay, I'll definitely do 29, but let me start with 28 because it's the same kind of question, but a little easier. I'm sure the algebra was the biggest problem in 29, but 28 is still a good conceptual problem to talk about. So let me start with 28. It gives you a function, 14x plus 8. Then it wants you to simplify the expression. And so we want to simplify f of x minus f of 9 over x minus 9. So my question, before I do any algebra, what does this mean? What does this f of x minus f of 9 over x minus 9 mean? Well, yeah, you can plug things in, but that's not what I'm asking. Right? I'm not saying you don't plug things in. I'm saying, what does this quantity represent?
That equation minus that equation with 9 plugged in where x is.
Yeah, okay, that's a little literal. Geometrically, this represents, I heard it.
Slope.
Slope. This represents a slope. You guys see that? Let me show you. First of all, you guys know how this graph looks? This function, 14x plus 8, what's it look like? It's a line, right? Pretty steep line, right? Slope 14. That's pretty steep. Through 0, 8, right? This is the y-intercept. So if I just wanted to wrap my head around this function, I could graph it by going to 0, 8, the y-intercept. Then I go up 14 over 1. 14 over 1. Get another point, which in this particular case, just because I wrote it here, let me put it, it would be 122. And then I would draw this line. So this is my function. So here's my rise. Now what is this? What does each of these represent? Well, f of 9 is a y value. Right? F of 9 is the y value when x is 9. So if I come over here to an x equals 9, say this is where x equals 9, then f of 9 is this y value right here. If instead of going to 9, I go to x, just some random x value, so here this is just x, and I go up to my graph, then this y value here would be f of x. So this is a difference in two y values. F of x minus f of 9, that's the difference in two y values. X minus 9, that's the difference in two x values. So this represents a slope. Because this function is a line, no matter what x is, no matter where I pick x, whether I pick x here, or I pick x here, or I pick x out here, I should get the same answer for this slope. Because it's a line, it only has one slope. What should my answer be?
14.
14. So without doing any work, really, you could tell me this is 14. Now, that's not always the case. Right? That just happens to be the case here because this function's a line. If I give you a function that's not a line, like in number 29, you can't use this analysis. But regardless, when you have a y value minus a y value over an x value minus an x value, you should think of that as a slope. Let's go ahead and do the algebra here. How would you do this if you had a picture and you hated pictures? How would you actually simplify this?
14x plus 8 minus...
Right. Minus f of 9. So let's actually calculate f of 9. Yeah, you do 14 times 9 plus 8 and plug it in. And if you calculate that out, it's 126 plus 8. is 134. So that's this guy here. He's really the only calculation I have to make because everything else is kind of given to me. Right? F of x is given to me. And so now I know f of x, I know f of 9, I can do x minus 9. So I should be able to write this all out. So this is going to scratch here. Okay, so then let's actually write it out. F of x minus f of 9 over x minus 9 equals 14x plus 8 minus 134 over x minus 9. Simplify what you can. 8 minus 134 is negative 126.
And then 14.
Right, I told you this should be 14, right? We all agreed this should be 14. So probably we can simplify this. On top, there's a common factor. 14 goes into both of them.
X minus 9.
So you're going to pull that 14 out, right? Factor out the GCF, and you're left with this. 14 goes into 126 9 times. So then this reduces. And you get what you thought you should get.
So you're saying if we're giving like a line?
I'm saying so many things, there's no way you could repeat them in one sentence. But go ahead.
Okay, so the first statement, you said if we're given a line, it'd be the slope. So
Yes.
whatever the slope is, that's the answer. That's
But if you're not given a line, which is, I don't know, 99.9% of the cases, you're going to have to do this calculation. So let's look at 29, because we're not given a line in number 29. 29 is anything but a line. So let's see, 1 over root x plus 15 is our function. And they called it g this time, huh? So let me call this g instead to be consistent. And then what we want to simplify or evaluate g of x minus g of negative 11 over x plus 11. So this is our quantity. Just, again, because I'm more interested in you understanding than actually being able to do the algebra. The algebra is important. Not as important as the understanding. Whatever this function is, I do know a little bit about this function. For example, can you guys tell me what the domain of this function is? Yeah, so if x is negative 15, that's a problem, right? Because your denominator is 0. In fact, you have more problems than that because you have a square root, and you can't have a negative underneath the square root. At least not if you're graphing. Right, so you can make a restriction, something like x plus 15 has to be greater than 0. Normally you would say greater than or equal to if it were a square root. But since the square root's in the denominator, you cannot have it equal to 0 either. So the domain of this guy is x has to be bigger than negative 15. Which is fine. And actually, at negative 15, do you know what behavior I have? What happens when your denominator is 0? You're going to have a vertical asymptote. Yeah, the function's undefined, fine. But more than that, you're going to have a vertical asymptote. Right? If your function's simplified and the denominator is 0, you're going to get a vertical asymptote there. So actually, I have, at negative 15, I have some sort of vertical asymptote. Maybe So, I don't know, maybe the graph, make sure I understand what this graph does. It goes to positive infinity, so maybe it looks like this, just for a sketch. I don't know. It should have a horizontal asymptote at 0 actually, so probably. But the point is, what does this represent on the graph? Right? This is saying if you pick x and you pick negative 11, so here's negative 11, here's some random x value, just whatever, it doesn't matter. And then you calculate the slope between the 2 points on the graph, this m will be what g of x minus g of negative 11 over x plus 11 equals, whatever the slope of that line is. And as you change x, right, if you move x over here, you get a new line, new slope. Right? So what that tells you is at the end of the day here, you're going to have x's left in your answer. Right? This answer depends on x. As this point moves, as this x value moves, this slope changes. So geometrically, this is what's going on. We're finding the slope of what's called a secant line. Now let's actually get our hands dirty and do this nasty algebra here. So g of negative 11, just like before, I need to calculate that before I do anything. What's g of negative 11? So you plug it in, right? 1 over square root of negative 11 plus 15, 1 over root 4. So this guy goes in here. G of x was given just like before. So now I can plug things in. This quantity is going to be equal to g of x minus 1/2, right? Because that's minus g of negative 11. All over x plus 11. So that's fine. It's not very simplified, though. So we have to do some more work. There's a couple of different ways you can simplify this. Well, not really. There's a couple of different steps you can do first. Right? Like some of you might want to rationalize this denominator first, or maybe you want to get a common denominator here, or maybe you want to flip this and multiply. There's a bunch of different things to do, and the order really doesn't matter. So you guys tell me, if you were simplifying this, what would you do first? Common denominator over on top here? Is that what you mean?
Yeah.
Okay, that sounds good. I think that's what I did in my other class too. So, we have a root x plus 15 and a 2. Those have nothing in common. Right? That would be like finding the common denominator between 1/2 and 1/3. They have nothing in common, so you do 3, 3, 2, 2. So over here, to get the common denominator, I'm going to put a 2 and a 2. Multiply by that. And over here, I'm going to put a root x plus 15, root x plus 15. Now you see the denominator here is 2 root x plus 15, and the denominator here is 2 root x plus 15, so they're the same. Do this now. So here, on the first fraction, I'm just going to get 2 over, well, let me do it all at once. Is it okay if I write 2 minus root x plus 15 over 2 root x plus 15 on top? Does that make sense? That's just the top. The denominators are the same, so I put it in a single denominator, and then I subtract it in the numerator. And then what happens? Yeah, so again, you got 2 things to do. You can either rationalize, right? You want to get rid of this root in the denominator, or you can bring this x plus 11 up. Well, kind of up. Multiply by the reciprocal. Right? So let me go ahead and, it doesn't really matter which one you do. I'll go ahead and multiply by the reciprocal first. So I can stop drawing this huge fraction mark. So this x plus 11 in the bottom here is really x plus 11 over 1. So you can flip this thing up and change it into multiplication. So this will be 2 minus root x plus 15 over 2 root x plus 15 times 1 over x plus 11.
And that's how far I went.
Okay, good. That's good. That's a good start. So then you can multiply, when you multiply fractions, you can just go straight across. So this will be 2 minus root x plus 15, because 1 times anything is the same thing. And then this will go in the bottom. Like this. I can't multiply this x plus 11 into the root, right? Whatever's underneath the root's trapped. So I just write it out in front. This is a pretty good answer. It doesn't match any of those answers, though, so we're feeling kind of
We should
depressed.
multiply times square root of x plus 15.
Right, we need to get the root out of the denominator. Right, the trick for rationalizing and getting the root out of the denominator is you just multiply by that same exact root, top and bottom. Right, this way you haven't changed the fraction because you did it to the top and the bottom. But when you multiply these two roots on the bottom, the root should go away. Right. Now, be careful. These are all multiplication here. Times, times, times. So there's no need to distribute anything here. Right? This would be like if you did 2 times 7 times 8 times 5. You wouldn't multiply the 5 times everything, right? You just do the 8 times 5 first, for example. So that's what I'm going to do here. I'm just going to do these two first. When you multiply a root by a root, the root goes away. So right here, we get x plus 15. Right, and the rest will tag along. What about on top? What do we have to do there?
2 minus x plus 15.
Right. Here you have to distribute because there is a minus or plus sign. So here, this root will get distributed here and here because of this symbol. It's not times. So what should happen when the root gets distributed is you get 2 root x plus 15 minus, again, root times root, the root will cancel. So you'll get minus x plus 15. All of that over the denominator. And if you distribute out this negative, you'll get one of the answers, I'm sure. Like A, actually, D is being kind of tricky, right? Because it's an x minus 11 to mess with you. It's actually an x plus 11. Let's give you the answer, D. On review. Oh, I'm sorry.
It is tricky.
Because it's tricky. This is a difficult algebra problem. You will run into, every now and then, difficult algebra problems. Because you can't do this problem doesn't mean that you should go work 1,000 algebra problems until you can. Okay? Because even if you went home and worked 1,000 algebra problems, I could find an algebra problem you couldn't do. Because it's just that big of a topic. There's just so much in algebra, people can't remember it. If you had a super hard time with this, you might want to isolate where you had a hard time and work some practice problems or ask for some practice problems. Like if you have a hard time subtracting 2 fractions like this, I can give you some practice problems like that. So if you had a hard time in any one step, let me know. And I might be able to find some help. does. Okay. Anything else give you heartache, headache, trouble, anger? Oh. Okay, so number 9 talks about the resistance. The resistance Y in ohms of 1,000 feet of solid metal wire at 77 degrees Fahrenheit can be approximated by the law. Okay, so I'm going to just put that over. So they give you this function, y equals 12,000 over x squared minus 0.46. They tell you, comma, this function is only valid for x values between 5 and 100. So this is like a domain. It's telling you this only works for x between 5 and 100. Then it says where x is the diameter of the wire. So remember, this y is supposed to represent the resistance of your wire. 1,000 feet of solid metal wire, 77 degrees Fahrenheit. So y is resistance, x is the diameter of the wire. Then, I don't know why, but then they tell you that x is the diameter of the wire in mils. Mils is apparently 0.001 inches. So in the parentheses there, they're just defining what a mil is. All right, if the diameter of the wire is doubled, the resistance is changed by approximately what factor? So it's asking you, it's also telling you in determining your answer, you can ignore the constant. So it's telling you to ignore this little 0.46 because it doesn't matter much. But it's saying, here's y, right? Here's some function y. If you calculate, let me call it y star because it's not quite the same thing as y. But if you calculate what happens when you double the diameter, how do you double the diameter in terms of math symbols?
You do f of 2x instead of...
Right, you'd plug in 2x in place of x. That's going to double your diameter. So you would look at something like 1,200 or 12,000 over 2x squared. Again, we're just going to ignore this. It's told us to ignore it. So. And now you compare this to what you started. Well, simplify it a little. How does it simplify?
3,000 over.
Oh, I'm not going to do the 3,000. You're right, but I don't want to put 3,000 because that's making it more cryptic. Right? If you square out the bottom becomes 4 and then x squared. So now compare what you end up with what you started with. What's the difference?
1/4.
1/4, because the 4 is in the denominator, right? So if you double the diameter, your resistance gets changed by 1/4. There's always a 1. So that's what they were looking for. E, I guess, is the answer. The resistance gets changed by a factor of 1/4 when you double the diameter. What if you... What?
Where'd you get the
I put it there. Now, what I'm saying is if the 4 is in the denominator, that's not 4 times something. So 4 in the denominator is equivalent to 1/4. Right. So I put the 1 here so you see that it's not C. You're not getting 4 times as much. Right. Your denominator is growing by 4, which is actually 1/4 times as much. So what if I would have asked, instead of doubling the diameter, what if I wanted you to triple the diameter? Right, so you see the pattern, you plug in 3x in place of x. But because of this squaring operation, you're going to get a 9 in the bottom. Right? So you get 12,000 over 9x squared. So now the resistance is changed by 1/9 because of that extra 9 factor in the bottom. What if I halved the diameter? Woo. 4. So if you halve the diameter of the wire, the resistance gets multiplied by a factor of 4. So here's another, here, I don't know, I'm just using that so you know it's a different function or a different whatever. It's not exactly the same thing as y. So if I halve the diameter, that will look like this. Which would give you a 1/4 factor on the bottom. 1/4 factor on the bottom is going to flip up. That 1/4 flips up and becomes 4 times your total resistance, your original resistance. Okay. What else? You guys got everything down? Feel confident?
Can you do 41?
41, 44.
Or 40? 40 or 41?
Let me do 40 and then talk about the main jam. Then you'll be able to do 41. So I'll do 40 and then I'll do 44. And then we'll have to move on to new stuff. So an open box of maximum volume is to be made from a square piece of material 22 centimeters on the side by cutting equal squares from the corners and turning up the sides. So first of all, they give you a diagram, which is very nice of them, much more nice than I would be. And they want you to basically use that diagram to come up with the volume of this box you're going to create. Okay? But my question is, where does this diagram even come from? Where do all these numbers come from? All right, if you're reading this and you see an open box of maximum volume to be made from a square piece of material, 22 centimeters on the side, you can start as soon as you read that and label square piece of material 22 centimeters. Because it's a square, these sides are the same. And you're going to make this box by cutting out equal squares from the corners and turning the remaining flats up. Equal squares is kind of what they're getting at with those dotted lines. That's a nice way to describe these equal squares you're going to cut out the cornering. So this is going to be gone. I don't know how much I'm going to cut out. And it doesn't say cut out 2 centimeter squares. Right? It says you're going to cut out some squares. So we label that our variable. I don't know how much I cut, so I cut, let's say, x here. Same thing here. Because they're equal squares, I get an x and an x here, an x and an x here, an x and an x here. That's why in the diagram up there, they have this length labeled as 22 minus 2x. Because you started with 22, but you cut away x and x. Right? This is x. And the same thing is going to happen on the other side. You start with 22, you cut away x and x. So this length right here will be 22 minus 2. Then you actually fold the flats up, right? So you fold these portions up to get this picture here. And the question is asking, what's the formula for the volume of this box? In general, volume is length times width times height for a box. Right, for a rectangular prism, I guess. But we can do a little better. Right? We have another expression for length, we have another expression for width, and we have another expression for height. So length, when you fold this up, the length is going to end up being this portion. Right? This black is the bottom of the box right here. This other stuff gets folded up. So this is going to be 22 minus 2x, that's your length. 22 minus 2x, that's your width. What's your height? X. When you fold up, this x that you cut out becomes the height. So here's your volume formula. Probably if you want to match what they have, you would write this as a square instead. So hopefully, we are going to be doing optimization problems, so you will see stuff like this again. But what I hope is that without this picture, you could get this one. Okay, with the picture, it's probably a little bit too easy. Without the picture, it's just the correct amount of difficulty. What about the domain of this function? So number 41 asks you pretty much the same, gives you pretty much the same situation, but wants to know just the domain of the function that you get. So instead of doing 41, let me just talk right here. What would the domain of this volume function be in y?
0.
Between 0 and 11. Yeah.
0 and 15. Oh, sorry, that's the.
Yeah, that's for the other one. So for this one, it would be between 0 and 11. Why?
Because you can't have a distance.
Yeah, so one in my head, one pretty easy way to do it, if this is the length, and this is the width, and this is the height, your restriction just has to say the length better be greater than or equal to 0. Or not equal to, better be greater than 0. The width better be greater than 0. And the height better be greater than 0. So you can take each one of these functions and say they have to be greater than 0 to find your domain. This guy you have to do a little work. Right? This guy you'd have to add the 2x over. Get 22 is greater than 2x, therefore x is less than 11. This guy's already done. So this tells you x is greater than 0, this tells you x is less than 11, so you'd have to be between 0 and 11. That's one way to do it. It's kind of a less thinking way, I suppose. Another almost equivalent way, but maybe more generic, instead of focusing on these functions, just look at what you're doing. You have a 22 centimeter piece of cardboard. You're going to cut a piece of it, a square here. First of all, certainly you can't cut more than 22 centimeters out of this, right? Because you just don't have any more than 22 centimeters to cut. Second of all, what happens if you cut like 20 centimeters? Is that okay? Why not? If you cut 20 centimeters out, you don't have enough to cut another square of 20 centimeters on the other side. See what I'm saying? You have to cut out 2 squares on the side. So you have to cut that 22 centimeters in half. That's the most you could ever cut out. That's where this 11 is coming from. And then obviously you have to cut out more than 0 or you wouldn't even have a box. Right? If you don't make this x bigger than 0, you got nothing to fold up. It's not a box, it's a piece of cardboard. So you can either think through it intuitively or you can set the length, width, and height greater than 0. Questions about that? Last one. Here we go. 44. Now, I'm glad you asked me 44. I'm very glad. I would have forgotten. So 44 says the motion of an oscillating weight suspended by a spring was measured by a motion detector. The data collected and the approximate maximum displacements from equilibrium are shown. The displacement is measured in centimeters. And and the time is measured in seconds. Take A to be this, B to be this, approximate the amplitude of the period of your oscillation. So the idea is that they're giving you a trig function. Right? They're telling you, because you have a spring oscillating, or a mass oscillating on a spring, you can model that by a trig function. And they're saying, for the trig function that fits this data, what would the amplitude and what would the period?
Can we just, by looking at it, decide the amplitude is going to be greater than 2?
You can do a lot of things by it.
No.
I don't know if that's one of them.
Less than one.
Let me redraw this picture so I have something to point out in yellow. Okay? So you have some sort of wave here, some sort of oscillation, and they give you 2 points. They give you this maximum displacement on each side. Or I guess maximum and minimum displacement. They tell you this guy is, where is it, A, 0.133, 2.49, is that right? And then they tell you this guy, 0.343, 1.7. The amplitude is the maximum distance that you go from the equilibrium. Okay? So you don't actually need to calculate it, but you need to imagine an equilibrium in here. And the amplitude is going to be this distance here.
So it's 0.71.
Divided by 2.
Right, so what you can do, what you can calculate with the information that they gave you, is you can calculate how far it is from this maximum to this minimum. Right, you can calculate this distance. But the amplitude is only half of that. It only measures how far from the equilibrium you go up, or how far from the equilibrium you go down. So this guy's bouncing between 2.49 and 1.78. Subtract those, that gives you 0.71, but you actually have to cut that in half if you want the amplitude. Which gives you 0.35. That's just the amplitude. Quick comment though. Hopefully, I don't know if you think this way, but it might behoove you to start thinking this way. Just by looking at the answers, you should have known that the amplitude is 0.3. Oh.
It's wrong.
Oh, these answers suck. These answers are terrible because the answer has to be C now. Right? Because it's the only one. No, well, I thought it was or A too. That's what I was thinking.
Oh.
But A is actually 0.335, which is 9. Right? So just by finding the amplitude, we were able to narrow this down. So you don't actually have to calculate the period. Unfortunately, this period is also wrong.
Yeah.
All the periods are terrible, right? Because this is, look at your time scale here.
It should be 0.44.
Yeah. Actually, I think 0.42 works. Well, we can calculate the period. We'll do that. But these are all wrong because they're way too big. Except maybe these two, but they don't work.
These too big, these too small.
So let's actually calculate the period, okay? So this is amplitude. How would you calculate the period?
Multiply the distance from A to B times 2.
Right, so imagine that this is a trig function and it keeps going forever, right? Keeps oscillating. The period is the distance or the time interval from here to here, for example. This is the period. Right, because after that it starts repeating.
You already have half the period.
You have half the period because a min is going to happen halfway in between these two. That's the structure of your trig function. So you can do a similar kind of calculation. Take this x value minus this x value. So do 0.343 minus 0.133. But that's not the period, right? That's half the period, right? Because that's only this distance. So then you're actually going to have to multiply that by 2. So this gets multiplied by 2. But 0.21 times 2 is 0.42. Yeah, so, yeah, the decimal point's in the wrong spot, or maybe they were trying to be tricky with units, but they didn't put any units on anything, so I don't know what they were thinking. Just an error. Just an error, I believe. So the period should be 0.042. Oh, I'm sorry, 0.42. Not 0.0. Okay. So I'm going to see you again Wednesday.
Yeah.
On Wednesday, we'll do a quiz.
On this review.
Yeah. Absolutely. We are going to do something new today, but the quiz will be over the review. And then the quiz next week will be over the stuff we did this week.
Which was review.
This worksheet. This is all your review material. So, look over this, make sure you can do it. A couple of things that you definitely want to focus on. Lines. You should be able to do anything with lines. Okay, find the equation of a line, graph a line. That's pretty much it. You should be able to do those things. Okay, there's a lot of questions on, well, there's a few questions about lines. Make sure you don't do this. And also graphing in general, right? The first few questions were about graphing. I will definitely have some graphing questions just to make sure you went back and refreshed on how to graph polynomials. But it'll be 4 questions, beginning of class. Don't be late.
It'll be like